Hello. We're going to look at two topics today. You've probably heard of these before. We have to review them, though. We have conduction and convection. So the first one I want to talk about is conduction. And this image gives an example of three types of methods that energy or heat uses to move through systems. Conduction, which you see in the handle of this boiling water, and the hand holding that handle. The heat in conduction moves through materials. So the heat from the boiling water transfers into the metal of the handle, and then that heat can continue to travel through the metal, slowly spreading out through the metal. That's conduction. Okay, let's look at another example here. Again, I have all three types in this picture: convection, conduction, and radiation. We're just looking at conduction, and conduction is when the energy moves through a material. So in this case, you had heat from the core through convection currents get to the upper mantle. So we're still talking underneath the earth, but now we're starting to get into rock, more rock than magma at this point. And that heat will move through the thick magma and the rock that makes up our crust, and it slowly spreads from the hottest point through to the cooler areas. That's conduction. It's moving through the material. And then one more example here that I'll show you from something that I made. Okay, I'm going to try and give you another example of conduction, so heat traveling through material. I've got a thermometer here that will take a thermal temperature of objects, and we'll put it right on the tip of this metal file. And I've got 78.8 degrees there. Now if I go up halfway, it's a little bit cooler, 73.2 degrees, all right? But let's turn the flame on. And I'm gonna let that heat. Now I just have the edge. I just have the edge of that burning, just the end of it. So the rest of the metal is out of the flame and a little ways away from the flame. So let's check the temperature now. Okay, I'm gonna first use this again on the front, and we're at 250 degrees, which makes sense, that's where the flame was. But now let's check halfway up. And that has even shown an increase of a few degrees as the heat travels through the metal, okay? A little bit closer to that tip, and it's 83 degrees as that heat travels through. And it can continue to travel through even after the flame is extinguished. So now it's up to 80 in the middle. And it should continue to rise as long as the tip here still has excess heat that can travel through the metal. Next we have convection. So we just talked about conduction. Convection is the next type of energy transfer we want to look at. And I have another image up here. That image is showing another pot of boiling water, which is fine. And then we're looking at these convection currents. And you see where the flame is coming from the bottom. That's heating up the water, right? So that water is going to be the hottest. And as it heats up, if you follow these red lines, and the arrow that's pointing at the red lines, it says hot, less dense water rises. So the hotter material rises up. That's the same whether it's air, water, or magma. That material rises to the top, and the water at the top is losing a lot of its energy, a lot of its heat. So it's actually cooler than the water that's rising up. And as it cools, if you follow these blue arrows, it says water cools, becomes more dense, and sinks. So you get this cycle that just repeats itself. The hottest stuff comes up to the surface, cools down, that cooler material sinks back down to be heated up again, and it's just a loop. We can see this in examples like a lava lamp. And if you're not familiar with lava lamps, they have a lamp at the bottom, and that lamp heats up the material inside. Usually the material is a mixture of like oil and water, or some kind of mixture along those lines. And you can see that these globs of oil, they heat up when they get down to the lamp at the bottom, and when they heat up they rise. So now this oil at the top has been away from the lamp, it's cooling down, and what's going to happen to that material at the top as it cools? It's not going to stay there. We should see it descend, and we see another glob here that's warming up, less dense, and now it floats up to the top. And some cooler material that's been away from the lamp drifts back down, and it just repeats. It just repeats these cycles. Another example here that's more relevant to what we've been looking at is convection currents within the Earth. And you can see this hot material rising up, and then it's going to spread along underneath the bottom of the Earth, the crust, cool down, and it'll sink back down into the crust again. So the hot material rises, and this is showing millions of years at a time, like millions of years a second. It travels along underneath, cools down, and descends back into the Earth. Hot material rises, cool material descends. Convection currents.